Today we're going to look at how we can factor quadratic expressions. Now this should mostly be a review for you since you've seen it in Algebra 1, so we're going to go kind of quickly through this. There are a couple different methods that we can use to factor a quadratic, and below are the ones that we're going to explore today. So the first one we're going to look at is the GCF, which is our greatest common factor. We're also going to look at when a is equal to 1, which is kind of like using a shortcut. We're going to look at when a is not equal to 1, in which we're going to be using grouping. We're going to look at two very specific cases, which is the perfect square trinomial and the difference of squares. Now, if you notice, I do have the when a is not equal to 1 highlighted in red. That one you can use for every single type of quadratic that can be factored. So if the other methods are confusing to you, as long as you understand how to do it by grouping, you could do any of these problems. So first we're going to look at the greatest common factor. This is very important because we always want to start with this one. If you don't take out a greatest common factor from the beginning, your numbers are going to end up being larger to work with, which is going to not be as easy to use. So by taking out a greatest common factor, we can actually simplify it in the beginning. So here are some examples. So if I wanted to factor each of these quadratic expressions, the first thing I'm going to look at is what they have in common. And when I'm looking for what's in common, I'm going to look for the number as well as the letter. So first we're going to look at the number here. So I have 12a squared minus 3a. As far as the number goes, I have 12 and I have a negative 3. So I wanted to figure out what is the common factor between 12 and negative 3. And that would be 3. So I'm going to take out a 3. I'm then going to look at the variable, and I have an a squared and an a, and I'm going to look to see what they have in common, and the greatest that they both have in common is an a. So 3a is going to be factored out, and then we want to see what we're left with. So when I factor something out, what I'm doing is essentially dividing by that. So if I have a 12 and I divided out a 3, I'm left with a 4. If I had an a squared and I divided out an a, I'm left with an a. And then here I have a negative 3a, and I divided out a positive 3a, so I'm left with a negative 1. And here we are, perfectly factored. Okay, looking at the second example, same idea. We're going to look at the numbers, so 6 and 9. I'm going to pull out the GCF of those numbers, which is 3. I have an n squared and an n, and I'm going to look for that GCF. In that case, we'll pull out an n. I had a 6n squared and I pulled out a 3n, so I'm left with a 2n. I had a 9n and I pulled out a 3n, so I'm left with a 3. And this is fully factored. Most of the time, we'll see quadratics that are written in standard form, ax squared plus bx plus c. And here's the situation where a is equal to 1. So a is the number that we have in front of the x squared term. So that could be any number. When it is equal to 1, this kind of makes our lives a little bit easier. So to factor an expression where a is 1, we just look at the c term, which is our last term, which is our constant, and we see what multiplies to c and adds to b. So here multiplies to 10 and adds to 7. So the two numbers that we can come up with would be 5 and 2, since 5 plus 2 is equal to 7, and 5 times 2 is equal to 10. Because that a value is 1, we can just write our factors as the numbers, so 5 and 2, so x plus 5 and x plus 2. A good way to check our answer is to try to FOIL it, and if we FOIL it and get what we started with, we know that we're correct. When you're testing these numbers, if c is positive, so if your constant is positive, your signs should both be the same, whether both positive or both negative. When c is negative, the signs here are going to be opposite signs, so 1 plus and 1 minus. Now there are multiple ways that you can factor. If you know a different way to factor and it works for you, by all means, please use that method. A lot of people try to do guess and check, and that might end up taking you a lot more time than if you were to just follow one of these methods that I'm showing you. Whatever works best for you. So let's look at some more examples of this. So here we look at number 1, right? The a value is 1. Oops. So we have to look at the c term. So here we know that c is equal to 20 and b is equal to 9. So we want to come up with two numbers that will multiply to 20 and add to 9. So those two numbers would be 5 and 4. Since 5 plus 4 is 9, and 5 times 4 is 20. Since my a value is 1, I can just write my factors as x plus 5 and x plus 4, fully factored. Number 2, okay, a again is 1, so what I'm going to do is look at my c term. C is equal to 30, and b is equal to negative 11. Two numbers that are going to multiply to 30 and add to negative 11. So I'm going to be using negative 6 and negative 5. So negative 6 plus negative 5 is negative 11. Negative 6 times negative 5 is positive 30. So I can just write this as x minus 6 and x minus 5. And again, we can always check our answer by foiling and seeing if we get the original expression. So now for number 3, when I look at 3, my a value is not 1. But remember, the first thing that we want to do is look for a greatest common factor. So if I look for a greatest common factor between all 3 of these, I can see that they all are divisible by 4. So I'm going to factor out that 4, which is my GCF, from each term. So here I have an x squared, then I have a 5x, and then I have a negative 14. So I'm going to treat the inside with the method that we just learned. So we have c is equal to negative 14 and b is equal to 5. So two numbers that multiply to negative 14 and add to 5. So we're going to use 7 and negative 2. So 7 plus negative 2 is 5. 7 times negative 2 is negative 14. So I can write that as x plus 7 and x minus 2. But since we pulled out that 4 from the beginning, we need to make sure that we bring it back in front at the end. So if I had FOILed just the x plus 7 and the x minus 2, I would not get what I originally started with. So we want to make sure that we have the 4 on the outside. So now that is fully factored. So here we have another method where our a value is not equal to 1. Now notice here in bold, it says that this method can be used for factoring any quadratic that is factorable. This is very important. So even if a is equal to 1 and you can use the shortcut method from the previous slide, if you're more comfortable using this longer method, please use this. It will work for any of the methods that we're going over today. To factor a quadratic trinomial where a is not equal to 1 and there is no common factor, rewrite the middle term, bx, as 2 terms, and then you're going to use grouping in order to factor this completely. So let's look at this example together. So we've got 2x squared plus 11x plus 12. So remember, the first thing you always want to do is look for a greatest common factor. So I'm looking at the numbers 2, 11, and 12. They do not have a common factor, so I can't pull anything out. Since my a value is not 1, I can't just look at c and just look at b. What I need to do is look at a and c together. So I'm going to multiply a and c. So 2 times 12 is going to give me 24. My b term is 11. So now I'm going to look at, for two numbers that multiply to 24 and add to 11. So we're going to use 8 and 3. So 8 times 3 is 24. 8 plus 3 is 11. So what we're going to do with this method is we're going to bring the first term down. So 2x squared comes down. We're also going to bring down the last term of plus 12. What we're going to do next is rewrite this middle term. So instead of 11x, what we're going to do is expand it by using the two numbers that we came up with. So we're going to write 11x as 8x plus 3x. Now the order that you write the numbers in does not matter as long as the signs are correct. So they're both positive, so it didn't matter here. But if the signs were positive and negative, you just have to keep the appropriate sign with the right number. So if I put the 3x here and the 8x here, it would be the same answer in the end. So now that I have 4 terms, what I'm going to do is I'm going to use grouping. So I'm going to group the first 2 together, and I'm going to group the second 2 together. Okay, and notice when I grouped the second 2, I kept the sign with the number. So I kept it with the 3x. So I'm going to look at my first grouping, 2x squared plus 8x. And I'm going to look for a greatest common factor. So here I want to look for the number and the letter that they have in common. So they both have a 2 in common, as well as an x. So I'm factoring out a 2x from both of these. So I'm going to be left with an x and a plus 4. I'm going to do the same thing for the second grouping. I want to keep the sign with my number, so whatever GCF I pull out, I'm going to use the same sign that I have here. So I have a plus, so I'm just going to put a plus here. 3x and 12, they have a 3 in common, so I'm going to pull out the 3, and then I'm going to be left with an x plus 4. Now, the key here to know if you've done this correctly is that the two values that you have inside the parentheses should match. So I have an x plus 4 and an x plus 4. If they're different at all, even if one of the signs is different, you've done something incorrectly, go back and double check. Okay, they should be the same. So then to write our final answer, what we're going to do is take the two terms that are outside, so the 2x and the plus 3, and we're going to put them together, so 2x plus 3. And then the two that are in the parentheses that are the same, we're just going to write it one time. And here is it completely factored. Okay. If we had tried to use the other method and used 8 and 3 and said we have x plus 8 and x plus 3, if you try to FOIL this back to check, you're not going to get the original. Okay, so we do not want to do it that way. If I FOIL this answer together, I will get what I started with. Okay, so let's look at another example. Okay, so factor the following. What we could do here is right away start with a times c, but remember the first thing that we want to do is always look for a greatest common factor. That will make our numbers smaller and will make this a lot easier to do. So first I look for my GCF. I look at all three of these and they all have a 2 in common. So I'm going to pull out the 2 and then I'm going to be left with a 2x squared minus 7x plus 6. Okay, so I'm going to leave this 2 on the outside alone for right now. I'm going to look at my a and my c. So I'm going to do a times c, which is going to give me 12, and my b term is negative 7. I need to come up with two numbers that multiply to 12 and add to negative 7. So we're going to use negative 4 and negative 3. So again, I'm leaving this 2 on the outside alone for now. I'm going to bring my first term down, which is 2x squared. I'm going to bring my last term down, which is plus 6. Then what I'm going to do is rewrite my middle term. So negative 7x, I will rewrite it using the two numbers that we came up with. So I'm going to write negative 4x minus 3x. Okay, so I've just expanded the negative 7x. Then what I'll do is I will group the first two and I will group the second two. I'm going to look for a GCF. So 2x squared minus 4x, I'm going to pull out a 2x, and I'm left with x minus 2. The negative 3x plus 6, remember I'm always going to take the same sign, so I'm going to take out the negative, and then 3x and 6 have a 3 in common. When I'm dividing the numbers, I'm dividing them by negative 3. So negative 3x divided by negative 3, I'm left with x. 6 divided by negative 3, I'm left with a negative 2. Again, check to make sure that your parenthesis terms are the same, which they are. They're both x minus 2. So now I have the two outside terms, the 2x minus 3, they go together. And then the x minus 2's are the same, so I put x minus 2. And now we can't forget about that 2 on the outside from the beginning. So we're going to bring it down and put it in front. So now here we have our quadratic fully factored. And we can double check by foiling it to see if we get the original problem. There is a particular type of quadratic called a perfect square trinomial that fits a pattern that we could use. If you don't understand this or this doesn't make sense to you, you can just use the previous method of grouping in order to factor these. Basically, sometimes you're going to see things written in a pattern. So for instance, if we look at these two that we have here, you could have the first term and the last term be perfect squares, and the one in the middle is 2 times the product of the two square roots, which kind of sounds a little bit confusing. So let's look at an actual example. So here we have a quadratic. If we kind of compare this to what a perfect square trinomial is, our a squared is our first term, right? So here they're saying a squared is our first term, which is 9x squared. And it says to find the square roots of a squared and b squared. So if I find the square root of a squared, right, the square root of 9x squared is equal to 3x. B squared is my last term. So b squared is equal to 4. If I take the square root of 4, I get 2. If I take a and b and multiply them, so if I look at this middle piece here, it's 2ab. I take a, I take b, so 3x times 2 is 6x. If I multiply it by 2, so 2 times that, I would get 12x. Okay, and that's what I have in the middle here. So it matches this pattern. So without having to do any type of factoring where I'm looking for like a times c and multiplies to that and adds to b, I can use this pattern and rewrite this as 3x plus 2, because that's my a plus b squared. So here would be my factored form. Now, if you don't understand this, which is fine, what you can do is you can just do the previous method. So do a times c, so multiplies to 36, adds to 12, and you can rewrite it, and you would end up getting 3x plus 2 times 3x plus 2. And when you have two of the same exact factors, you can just write it as one of them squared. Okay, either method is fine. I just wanted to show you this perfect square trinomial because this will come up sometimes, and it's a lot faster if you can recognize that it's a perfect square trinomial. But if you can't, there's no problem in just using regular factoring. Another specific one that's actually very important, this one's actually really good to remember, is the difference of squares. Okay, so you can use regular factoring where you're using grouping in order to factor these as well. But again, it's going to be a lot faster if you know that it's a difference of squares. So difference of squares happens when you only have two terms. Your first term is something with the x squared, and the second term is your constant, and there must be a subtraction sign in the middle, right? It's called difference of squares, so there must be a subtraction sign. If it's an addition sign, you cannot use this. Basically, what we're going to do is take the square root of each of these, and then we're going to write them as 1 plus and then 1 minus. So for instance, my x squared, if I take the square root of x squared, I get x. If I take the square root of 16, I get 4. So to factor this, I would have x plus 4 and x minus 4. And this would be fully factored. Now you could always double check by foiling it together. In the second one, again, I'm going to take the square root of 9x squared, and that's going to give me 3x. I'm going to take the square root of 49, and that is going to equal 7. So when I write them as their factors, I'll have 3x plus 7 and 3x minus 7. Okay. If you notice that they're opposite signs, the reason for that is when you actually FOIL them out, the positive version and the negative version will cancel out. That's why you see in the original problems there is no plain old x term. There's only x squared and the constant, because the x squared is going to the x term is going to cancel out. Okay, so you could use regular grouping for this. Your b term, you would just call it 0. So when you're trying to factor, you can do that, but it's a lot easier to remember these difference of squares formulas, because that's going to make it a lot faster for you to factor these. Okay, so for your homework, you're going to try the following quadratics and factor them.